All right. So as we were saying, these are the 3 blocks of code that are necessary in order to set, get, and verify the presence of cookies. Now, to give a little bit of background on cookies, you guys, if you're to look inside of your browser caches, there's probably thousands of cookies there right now. And I'm not going to go and dig into my browser, but you can go ahead and look into cookies and site permission. And you can begin to look at all the sites that have maintained cookies here. And I'll let you get into that and go and check out everything, recent activity. And so the vast majority of cookies have everything to do with advertising. So there are 10 major digital advertising companies, and Google is, of course, the top one. And there's a cookie that Google sets, and that cookie identifies you. So it maintains a consistent piece of data, and there's a schedule for the elimination of cookies. I think the Google cookie is scheduled to be deleted in like 10,000 years or something along those lines. So it means that the longer that cookie is set, the more potential for collection of data on your web browsing habits there are, and the greater the opportunity for customization. Indeed, if you guys were to delete the cookies on your device, it would probably sign you out of a lot of things, which is fine. But then it would also halt the data collection on your browsing activities. Now, this is a sore way to begin the lecture, and it's a very, it's at the very heart of web privacy itself, which is, can people store data on the decisions I make while I'm online? And the answer is yes, insofar as they have installed a cookie system into their websites. So these are the 3 blocks of code that are necessary in order to write cookies. Now, just to give and so it'll be very easy for me to have you guys set a cookie. So you would set it this way, and you create an expiration date that's built on, sometime in the future when the cookie will become invalid. That's fine. And so you'll set the cookie. Now, there are really going to be a number of cookies that get established. So a cookie gets established every time there's a fact or a piece of data that you want to keep on a user's computer. So what happens when they are using your site is they have the opportunity to read, that site has the ability to read the cookies that belong to it. And there may be other permissions that are related to cookies where one site can read the cookies of other sites. Does that make sense? And so Facebook has been trying to make a ad system for years. Google, of course, has been the original sort of internet advertising platform. So other people are using the Google cookies, and it's because they're using the Google service. And Google is, I forget what their revenue, I think it's a 20, I would throw 20 billion a year in revenue. Maybe that's true. They're about as valuable on a per annum basis as Goldman Sachs. It's a 20-year-old company. It makes the same as a 100-year-old investment bank. And the very premise for Google's monetization is the cookie. And so long as there's a cookie inside of the browser that's related to Google, Google can collect data on you each time you go back to their website. So if you go back to google.com to do a search, google.com can read cookies relative to their service in your browser. So if you guys go ahead and, I won't make a distraction of reading the cookies in my browser. I'm sure there are thousands whenever I go there. And I actually don't look at my cookies very often because frequently when I look at the cookies, they're from all sorts of sites that I don't remember ever visiting. And it's because I remember the sites that I look at. I look at Zero Hedge, I go to Costco, I go to tradingview.com, I go to tradingeconomics.com. Within those 4 or 5 websites, I go to Coursera, I go to Cal Poly, I go to Canvas. Within a few of those sites, there are advertising networks that actually are third party and that are not related to Zero Hedge. So let's go to Zero Hedge. And, Snowflake alert, you may not be of the political variant of Zero Hedge. That's fine. Love you anyway. But if you take a look at all the stuff here, there's all sorts of terrible advertising. So here, let's say I go ahead and start using it, and it already begins to load. You can see that the bar has begun to load. It's begun to load the various advertising platforms that it's using. And I think as a free information source, they probably use 6 or 7 different advertising networks on their website, and that's to give them some degree of monetization. Zero Hedge is very popular among traders and kind of, the renegade Wall Street set. And so I think I've got some pop-up blockers, but it's blocked a lot of different content from it. And I think I've disabled my ad block. And that's to give them a chance, because oftentimes you get blocked from websites if you do not have an ad block on. But Zero Hedge, I think I read their site maybe 3 or 4 times a day at minimum. It's kind of my news source. Everybody has a news source. Zero Hedge is mine. But the only reason why I bring them up as a topic is because if I were to look inside of my cookies, I'm sure I would find cookies from websites that I swear I haven't visited before. And those are primarily, and I could go through it right now, that'd be fine. But I don't want to create a distraction here. But if you go through your cookies, you realize that there are many sites that you've never visited before. And these are ad networks that are actually JavaScript code that's been embedded within a website that posts advertising. Now, I will laugh because I used to do this test where I would load the LL Bean, which is a fairly boring website. You go to LL Bean, which is a great place for backpacks. It's a great place for boring professor clothes. Almost like they give you kind of a professor starter kit on the first day of your job. They're like, hi, welcome to Cal Poly. Congratulations, you've been selected. Here is a gift certificate to LL Bean. You'll want to go there and get some professor clothes so that you look nice, but you don't look, too nice. And so so that's fine. I go over here. And then traditionally I would go back, to my steadfast Zero Hedge. And very gradually I would see LL Bean ads on the Zero Hedge. And the reason why is LL Bean is not advertising on Zero Hedge. LL Bean has no direct relationship with Zero Hedge. What LL Bean has done is they have partnered with various ad networks, and they've purchased advertising on various digital advertising networks. And then Zero Hedge, as a crummy, money grubbing, finance website, they have probably as many online advertising as they can. And nothing has appeared yet. I wonder if I have a blocker on that I've lost track of. But what happens is the advertising networks on the Zero Hedge website see cookies that have been left by LL Bean. And because LL Bean has left cookies there, the online advertising networks look within the prioritization of clients that have paid them in the last week, and they say, who's paid us the most? And they will retarget advertising for those clients who has paid them the most. And so this is called retargeting. And so there's probably hundreds of brands, that are paying for such services, but LL Bean just happens, because I'm a professor here, and this is what we do, is we always keep up with the latest LL Bean flannels, in a never ceasing arms race for professorial fashion. And it senses that LL Bean is the site I've visited the most. So LL Bean is going to be the one that I see. Now, the trends in advertising change quite a bit. Google.com. This is kind of the original. Oh, and let's just search for LL Bean. Great, LL Bean Master Pack. Welcome to campus. And so traditionally, you would see ads along the side of the side of Google. And this is kind of the original advertising. What Google has done is they have dispensed with the side advertising. Instead, they have integrated advertising into these results. So these e-commerce opportunities probably have some degree of competitive bidding. Now, Google's an interesting company. It's in many ways the center of computer science and algorithms, just by virtue of their profitability, by virtue of their commitment. Our field, computer science, has just grown a great deal since the arrival of Google. Let's face it, there's an incredible synergy, and we wonder if we are giving more to Google or if Google is giving more to us. And the truth of it is, in 15 years, there will be Google's bachelor's degree in computer science versus Cal Poly's bachelor's of science degree in computer science. And you will have a choice between Google's, which may be free, and which will probably be better than any given university degree. But it will be free because they want to grab hold of all the world's emerging young programmers.
I'm sure universities are going to be happy about that.
They're going to love it. They're going to love it. But those of us in the CIS area need to keep our program quite good because Google is doing good work in that arena. But back to the idea of cookies. So how can the online advertising universe work? And the essence of it is the cookie, and the essence of it is code like this. So let's go through these three mechanisms in very Karate Kid fashion. So wax on, wax off. What we've done here is just to create a simple web page, and there is no body. There's just a JavaScript. And what it will do is the first thing it will run is when the body loads, it will check cookie. It will run check cookie. And check cookie says, grab a cookie by the name of username. Go ahead and look for a cookie by the name of username. And then if the username is empty, i.e. there is no cookie by the name of username, then say, or rather if the username is not empty, then go ahead and greet him or her. Otherwise say, well, what is your name? And then use that name to set a cookie by that name. And so we have two mechanisms, get cookie and set cookie, that we need to be able to create. So get cookie takes the name of the cookie, which implies that there can be a number of cookies with different variables. So it really does two things. It checks for the name of the cookie, and then it asks for, is that cookie owned by the site that I am visiting currently? It's the same origin policy. Does that cookie belong to the site that I'm currently looking at? Do I have the right to read other people's cookies? No, I get to read the cookies that are placed by this site. And so go ahead and look for a cookie by that name, and go ahead and break up the values inside of that cookie, and go ahead and return whatever the value, whether that cookie is there or not. Now, within the space of this lecture, I'm not going to take apart substring and charet. That's a separate. These few lines deserve their own lecture, and it may or may not have been covered by your prior Java programming class. But basically what it's doing is it is doing a search for a cookie based upon the name that you are giving it, and it has to take apart the name of the cookie based upon the characters at given positions.
So the for loop.
That's the very, that's right. Now, for loops are worthwhile repeating, but we have a lot of other things to go through, so I'm not going to hijack the class in favor of reteaching the for loop. But the for loop is going to help you. The for loop is very much worth your time. What I find with the for loop is that the for loop is always 3 elements. It's never more, never less. There's always a limit. So the for loop can keep working until it reaches a limit. So you specify a limit in the middle terms. Frequently, or most frequently, the limit is the length of whatever array that we're currently working with. So an array is a collection of data. And an array, we understand how long the array is or how many items are in that array. But we want to tell the for loop, begin with the first item of the array, and until you reach the end of the array, go from one item to the next item until you reach the end of the array, signified by the length. And so the for loop gives you kind of if you're a math person, it gives you a sigma capability. It gives you the ability to understand a data set in its whole, and they say, for like in the sigma in calculus, we move from the start of a data set until the end of a data set. And for every step, we're going to do the same exact thing. So we're going to do a programmatic iteration, or we're going to treat every row of that data the same way. Oh, and here we are doing a free for lecture. Here we are. Let's do it. And so for every item within that data set, we're going to do the following steps. So the heart of upper tier, college mathematics is the sigma. It's the big, it's the sigma symbol. And the sigma symbol is very important to us because it basically represents the for loop. It means that at the top we have a limit. And in the middle of the sigma, we specify a operation, or we specify a set of things that we're going to do upon every element within that array. Excuse me. Thanks. And so for every element of that data set, we want to do the same thing, which is powerful. And in many ways, the for loop resolves hundreds of years of calculus by saying, here is what mathematicians have been asking for since the early days of Descartes, from the early days of calculus, is can we take a large stack of data and then somehow evaluate every row of that data? And the instructions to evaluate are within the for loop. Whenever happens inside the for loop, we're saying, hey, please do these steps to every row. And so in the case of the get cookie, and maybe this is a practical application of the for loop that you've been looking for, like, cool, the web. How do we make iteration, or how do we make for loops work for the web? And one of them is the cookie. Or we want to say, well, go ahead and take apart the name of the cookie, and then go ahead and split apart the cookie that we find and verify that we have it there. Now, if we can't get the cookie, if we can't find a cookie based on username, then we're going to set the cookie. We're going to actually create a new cookie. Does that make sense? And you'll find this happening a lot when you're visiting different web pages, where I'm going to go ahead and set, given a value. So what should the name of the cookie be? I'm going to set that. And then what should the value be inside of that cookie? Understand that cookies can only do one thing. They can only store one piece of data, and they can supply a name to it. So you can see the immediate application or the use of a cookie for a program, because basically a program can grab a piece of stored data that already has a name. So the program can ask for the data by name, and it can get back that data by name. It's a key value storage situation. And it's very efficient and fast, and it's pretty much powered the web heretofore. Now, if I were to say to you, Google wants to do away with cookies, you'd probably say, well, what are they going to do if they don't have cookies? What if they can't store data locally within your browser? And really, the answer that Google says is that, well, we're working on different data aggregation patterns. So we're going to actually classify your ads based upon your IP address and various other attributes of the area where you live. Does that make sense? And various other clues will help us understand who you are and what some of your demographic and psychographic dimensions are. And so this, in many ways, is the outcome of the Sergey Brin data mining focus. Sergey Brin is one of the two founders of Google. Larry Page is really more focused on hardware and more focused on distributed computing, more focused on the topology of the internet, at least originally. I'm sure he's into different things now, But when he was a graduate student, very interested in the hops that the internet takes, the hyperlinks, the mining of the links on the internet. This is the Larry Page emphasis. But the spirit of data mining, the spirit of data science, that's Sergey Brin's angle within Google. So when you take a look at Google right now, you have a combination of the two personalities. You have the huge warehouses full of custom-built computers that are all over planet Earth, and they're collecting the semantic value of links. That's Larry Page. That's the back rubber. But then you have the secondary component of Google, which is the data mining or the treatment of the Pagean data set for its value. And so the modern culture of the internet is built upon the cookie, where the cookie gives us a chance to store a bit of individuated data on web usage. And so for Google to come out and say, well, we want to do away with cookies, we want to have an internet without cookies, what they're saying is we want to eliminate all the competition, because very much the rest of the internet is still very dependent on cookies. And so when you eliminate the ability for other people to set individuating advertising data on devices, if you eliminate that, you eliminate other companies' ability to collect data, because virtually no other company has the ability to amass and do data science upon web scale data like Google does. No one really has that capacity. Google was really the first to move in that direction, to create a custom data center topology to collect that data, and they're in a singular position to handle it. So if Google were to somehow operate without cookies or prohibit cookies from Chrome, they would probably find themselves in Bill Gatesian antitrust territory, because most of the rest of the world needs cookies, uses cookies, relies upon cookies for data science in the internet. Does that make sense? So I think these, I don't know, how many lines is that? Lines 6 through 33. The 27 odd lines there, 25 odd lines. This is kind of your ticket to understanding how your users operate. What facts can we collect from our users in an orderly way that helps us to customize their experience? And another question is, can we go without cookies? Is there a way to not set cookies? Can we just have everybody authenticate? Does that make sense? Now, what I appreciate about a lot of what we call the permissionless or the Web3 is that you have a wallet, and a website connects to your wallet, and it sees the wallet, but it does not require you to authenticate. And it's a pretty interesting experience to have a crypto wallet and to not authenticate to something, and that the site does not actually ask you to authenticate. It's a permissionless environment. It's a very interesting experience. You just show up to the website, you begin using it, it recognizes your wallet, you authenticate the wallet to it, and then forever you are using the website. I think it's a very small step, but it's still very cookie dependent. To do a permissionless web, you still need to have cookies that get set. So one of the facets, and here I'll just pause the video for a moment, we'll go ahead and take a look at the assignment, and we'll say to people, hey, let's run this code today. Let's fool around with this code, download it, code it, use it. And then let's talk about implications. What does it mean? And then how do we apply it to get a grade in the class? The all-important question, right? We need grades to make people invest and care. And then how would we use cookies going forward? So I'll pause the video, and then next time we start the video, we'll talk about how the project will work. Very good. So let's go ahead and use this link right here to check out. That will link to our, what I call the cookie sampler. And that'll allow you to grab this code, and we will do a bit of experimentation with it. So module 12 is where I currently keep all of the cookie stuff. And let's go ahead and take a look downstream, because you guys are now in a position of doing the phase 2 deliverable. And I mean, there's a difference between teaching something and then asking somebody to do something with it. But once you have taught enough, they can begin the process of piecing together a solution. So firstly, we're going to do an authentication screen. And it'd be better if you had a bootstrap, maybe a 5.2 bootstrap. Then there's some example code that you can download here. And then you should have a button there. After the user presses the button, read the content of the text boxes. If there is input in each text input, declare the user authenticated. So there doesn't need to be any actual password matching. They can just type and then be passed. So there's no actual string matching because there's no server. If you'd like to do a little password matching, then more power to you. Pass this to the console via console.log, then set a cookie. And so I believe I linked to the GitHub declaring the user to be authenticated. After the cookie is set, navigate the user automatically. We did that last lecture. per this example. This example gives you a technique for moving the user to a defined page. We'll call this for the landing page, and it should be a page you've already built in your project one. So there's an authentication. You're going to investigate what they've typed. Then you will authenticate everybody. You will skip actual checking, press a button, and move them, programmatically navigate them to a landing page. You will set a cookie declaring them authenticated. And then once they land, you will have a sample here on how to verify that they are authenticated. And then you should check these samples out and then attach a click event via add event listener. When the visitor reaches your landing page, read the cookie. If the cookie says they are authenticated, show an alert that says welcome back. And that's a nice set of skills where if you were to show up anywhere and you'd say, but I did a cookie-based authentication, you would be a serious contender. We can have you aboard here because websites are about content. Websites are about what we are saying. But developers are less integrated with what we are saying. They're more interested in what mechanics are we using to keep the website secure, what mechanics are we using to collect user data, what are we doing behind the scenes mechanically, to enable communicators. And then we have a few examples here, and then I have some tutorials. So good. So think about, okay, you now have a ton of skill in your tool bag where you can work, I think, between now and maybe the end of the month on this project. And when we come in every time going forward, we should erect some of the scaffolding and help people put together those pieces.